Hello, my name is Bradford Walker, and today I'll be presenting on oil and gas extraction, a topic deeply connected to both the geology we're studying and the infrastructure we rely on every day. As someone working in Texas and pursuing civil engineering, I see the impact of oil and gas firsthand, from pipelines to roadways. Here's a quick look at what we'll cover today. We'll begin with how oil and gas forms, then move into how they're extracted from both by traditional and modern methods. We'll also explore technology advances, environmental impacts, and finish with what the future might hold for this essential industry. Oil and gas are fossil fuels made mostly of hydrocarbons. They're formed from the remains of ancient marine organisms. These fuels are the backbone of global energy, powering cars, homes, and entire industries. Natural gas, for example, made up about 32% of the US's electrical generation in 2022. The formation begins when plankton and algae die and settle on the sea floor, then get buried under layers of sediment. Over millions of years, heat and pressure transform this organic matter into hydrocarbons. These then migrate upwards until they get trapped into porous rock beneath impermeable layers, creating a reservoir. Oil and gas are found across the world. The Middle East holds the largest conventional reserves, while the US leads in unconventional production thanks to the shale plays like out in Odessa in the Permian Basin. Offshore drilling also plays a key role, especially in the Gulf of Mexico, which helped produce over 15% of the US's crude oil in 2023. Conventional extraction uses vertical wells to access reservoirs. Oil is pumped to the surface using rigs and pump jacks. It's most effective when deposits are easily accessible, which is why many older fields still rely on this method. Unconventional extraction includes horizontal drilling and hydraulic fracturing, commonly known as fracking. Fracking involves injecting high pressure fluids to crack shale rock and releases trapped hydrocarbons. While it revolutionized U.S. production, it has also been a focus of environmental debates for years. Offshore drilling allows us to tap into deep water reserves. These massive platforms can drill thousands of feet below the sea floor. Though expensive, the method is vital. These offshore fields are expected to account for nearly 30% of the global oil production over the next decade. Modern technology has transformed extraction for the better. Seismic imaging helps locate hidden reserves. Directional drilling allows precision control of the well path. Real-time monitoring systems enhance safety and efficiency. These innovations reduce the cost and help access reserves that were once unreachable. Oil and gas extraction has its consequences. Fracking has raised concerns over groundwater contamination and has induced earthquakes. Methane leaks during production contribute to climate change. That's why agencies like the EPA enforce regulations to reduce air and water pollution to protect public health. The future is always unknown, but we always got to keep a balance with it. So, in oil and gas, it'll always still be a part of our energy mix, and it will be for decades. But innovations like carbon capture, green fracking fluids, and hydrogen fuel are reshaping the landscape. As engineers, we'll play a key role in designing cleaner, safer systems. The future includes cleaner tech and a move forward towards renewables. But oil and gas will likely remain key for decades. Oil and gas have fueled progress from cars to construction, but they have come with responsibility. Our challenge now is to meet energy needs while protecting the planet. Understanding how these resources work geologically gives us the foundation to do just that. These were the sources that I used for the presentation. Give them a look. They gave me a lot of information. I expect they'll do the same for y'all. Thank you. Have a nice day.